All right, so this is, let's see, how many lessons do we have after this? Is this the last one? 37. We got 6-6. We got 6-6 and that's it. All right, so we are getting ready. Have a test sometime soon. All right, so it goes to 6-6. All right, let's take a look. We've talked about parallelograms and all that kind of stuff. Well, are these parallelograms? No. Why are they not parallelograms? Why is a trapezoid not a parallelogram? Very good. It's got one pair of parallel sides, but a parallelogram has what? Two pair of parallel sides. Okay. What about a kite?
No.
It doesn't have any parallel sides. Okay. It doesn't have any parallel sides. So a trapezoid only has one pair of parallel sides. Kite doesn't have any parallel sides. But it does have some stuff that are equal and things like that, but no parallel sides. All right, so let's talk about a trapezoid. We're going to talk a little bit about a specific trapezoid at first, but then the last thing we talk about today for trapezoids, we're going to talk about just a general trapezoid. But today we're going to talk about a specific type of trapezoid. I think we even mentioned it on the quiz. We had one on the quiz. You remember what specific type of trapezoid that we talked about? An isosceles. Very good. It's an isosceles trapezoid. So let's draw an isosceles trapezoid. So that's one of the parallel sides. Okay, we'll do that. And what I'm going to do is copy and paste. And then I think if I hit transform, can I, is it? In my other program that I have, I can flip it super easy. I just forget. Which one? Is it shape? Maybe I can do this. Boom. No, that's not it. Shh, guys, this is not a free time to talk while I'm trying to figure something out. We've talked about this a million times. So just because I'm looking down here trying to figure something out doesn't mean you go into your own conversations. Just sit and watch and let me just watch as I'm trying to figure this out. And I should have had it figured out. There should be a thing that just flips it along an axis. And is it one of these? It's not that. Is it that? No. Is it this? Oh my goodness, what I just do? I don't know what I just did. I don't know what that was. A layer. Let's get rid of that. I don't know what I just did there. Well, anyway. Or maybe I can right click on it. Maybe that'll do it. So watch. If I right click, everybody's watching, right? Okay, transform. There we go. Reflect. That's what I wanted right there. Now I know how to do it. Okay, now if I can just grab the thing. There we go. All right, so now the reason I wanted to do that is because I wanted it to be the exact same angle and length and all that kind of stuff. All right. So, and now what I can do, I'm going to be using this trapezoid a lot, so I'm just going to copy and paste it. So I've copied it. Actually, let's group it together. So if I just group it together, then if I just move one, it moves everything. Then I'll copy that. Okay, enough of that. Oh my goodness. So now this is an isosceles trapezoid. Why? First of all, why is it a trapezoid? Because you have, it's kind of ugly, because you got one pair of opposite sides parallel to each other, okay? Now, specifically, this is an isosceles trapezoid because, what do you think? You have one pair of congruent or equal sides, okay? You already got the parallel, it makes it a trapezoid, but why is it isosceles? Because one of these sides is equal to the other side. Everybody see that? So if you got two sides equal, then it's an isosceles trapezoid. Everybody good with that? Okay. So we have a theorem that says this, okay? And I'm not going to, again, just like yesterday, I'm not going to write down the theorem, but if you want to write it, it's pretty short. It's in the book. It's on page 277. It says the base angles. Now, what do we talk about the base angles? The base angles are the angles that are formed by the parallel side and one of the equal sides, okay? So this right there is a base angle. But this one right here is also a base angle as well. Does it look like these two are equal to each other? No. So I'll put one arc here and two arcs for that, just to show they're different. But this theorem says this, that the base angles of an isosceles trapezoid are what? What do you think, just off the top of your head, what do you think is true about this one and this one? Yeah, they are. They're congruent to each other. Okay, they're exactly the same. There is a proof that they do on example 1. I'm not going to do the proof mainly because of time, but you can look at it if you want, if it makes any sense to you. But this is true, that this angle and this angle are equal to each other. Now, this is also a base angle, but it's a base angle with another line. So what do you think is true about this top angle and this top angle right here? They're congruent to each other. Anthony, you have a question?
Can I say, like, does it have to be, like, on that side, like, on the right side, I mean,
No, because it's got to be between the parallel side, that one parallel side. See this parallel side right here? So it's only the one that connects that one parallel side to this. We call this a leg. This is a leg. This is a leg. This is a base. And this is a base. Okay? And so it's only the ones that are equal to each other just connect the same bases. See how this connects the bottom base? This connects the bottom base. So only those two are equal. So even though this connects a base and this connects a base, they're two different bases that they connect. So they would not be equal to each other. What would be true, that there's not a theorem, but we know since they're parallel lines and this is a transversal, what could I say about this angle up top here and this angle down here?
equal 180.
Okay, give me a good word though. Supplementary. Okay, they're supplementary. And you're right, they add up to 180, so you wouldn't be wrong, but I wanted that word, okay? That they are supplementary, which means they add up to 180. Everybody understand that? Okay, so that's some new stuff that we didn't know about a trapezoid. Really, the only thing we knew before today about a trapezoid is that these two sides were parallel to each other. Okay? All right? So that's our first theorem. Well, that wasn't so hard, was it? Now, if you wanted to, you could put some letters in here. This is the letters that they use in the book. That's K, J, this is I, and this is H, H-I-J-K. All right. So you could say this. Let's just write this down just so we can see it. So we could say that angle H is equal to what? Angle I. And what else is true? Angle K is equal to angle J. All right. By this theorem, that's what's true. Okay. That's basically what this theorem says. All right. That the base angles of an isosceles trapezoid are congruent. Remember, it's got to be an isosceles trapezoid. It's not just any old trapezoid. Right? If this leg right here went out further, like way out here like this, then those two base angles would not be equal to each other. Does that make sense?
Yes.
Okay. Only if these two legs are equal are the base angles equal. So that's pretty important. You'll be using that. Here's another theorem. Well, this one kind of is the same way. Do you remember how we've been doing this lately? This one says they say that this is an isosceles trapezoid. So what can you say about the two base angles? That they're equal to each other. Now, you could also say, well, what if you just had a trapezoid? We don't know it's isosceles, just any old trapezoid. But what if you had just an ordinary trapezoid, but the base angles were both equal to each other? Then what kind of trapezoid would that be then? It'd be an isosceles trapezoid. You see the difference? The first one, the one we did right here, is that you started off knowing that this was an isosceles trapezoid, okay? But then, this next theorem, and we did this before, didn't we, with some quadrilaterals, parallelograms, and stuff like that. We said, okay, this is just a trapezoid. I don't know for a fact that this side and this side are equal. Everybody understand? So it's just a trapezoid. So I do know it's a trapezoid. I do know that this and this are parallel. But what if I told you that this angle and this angle were equal to each other? Then what could I say about that whole trapezoid? I could say that trapezoid was a what kind of trapezoid? An isosceles trapezoid. So given this information, okay, I can now say that this is isosceles. Does it make sense? So the theorem says this. If a trapezoid has one pair, just one pair of congruent base angles, then that trapezoid is isosceles. All right? I don't even have to know that both of the base angles are equal. I just have to know that one pair of base angles are equal, and then this thing is an isosceles trapezoid. Okay? It's kind of the same thing, right? Just a subtle difference, all right? Just a difference on what's given. All right, enough of that. Then we have one that talks about the diagonals. So let's scooch that out of the way. Let's do this. And let's make the diagonals a different color. You remember what the diagonals are? It just goes from one vertex to the other.
Yeah.
To a non-consecutive vertex is what we would say. Yeah, but we did it with a parallelogram. Okay, so now we have a trapezoid. And yeah, so we know already it's a trapezoid, so I know that this and this are parallel to each other. Agreed? So again, what do you think, just off the top of your head, looking at this thing? Now, that's not the greatest way to come up with a proof for a theorem, just because it looks like it. Okay, so we're not really proving it, but just off the top of your head, what do you think might be true about these two yellow lines right here? Well, they intersect each other. No, they don't intersect each other. No, that only happens on a parallelogram. Okay? Or actually, no, it only happens on a what? A rectangle, right, where they bisect each other. Okay, but so they don't bisect each other. But what's true about that whole yellow line and this whole yellow line right here? They're not perpendicular. They're what? They're equal to each other. They're equal to each other. Okay, well, I didn't hear you. You got to speak up. So they are congruent to each other. They are equal to each other. And that's what the theorem says. Now, here's what it says. It says it kind of weird, but let's see what it says. Again, I'm not going to write it down, but it says a trapezoid is isosceles, okay, if and only if the diagonals are congruent. What is that if and only if? By the way, here's that phrase, if and only if, is a very, very common phrase in geometry and in math. And a lot of mathematicians shorthand it by doing this, IFF, if and only if, all right? So it says a trapezoid is isosceles. So it's isosceles if and only if the diagonals are congruent, okay? Now, what does that if and only if means? It means it could go both ways. So this says it's an isosceles, I'll just do a little symbol for trapezoid. Okay? It's an isosceles trapezoid if the diagonals are equal. So if these diagonals were equal to each other, then what kind of trapezoid is this? It's isosceles. Now this also says, I'm sorry, I kind of said it the wrong way. If it's an isosceles trapezoid, then the diagonals are equal to each other, right? But you could go the other way and say if the diagonals are equal to each other, then it's a isosceles trapezoid. That's what that if and only if means. It goes both ways, right? I could go from here to here, or I could go from here to here, and they are both true. Both of those statements would be true. Does that make sense? Yes, that's only isosceles. That's correct. That's only for an isosceles trapezoid, okay? So if you just had a regular old trapezoid, the diagonals would not be congruent to each other, okay? But if it's isosceles, which means if this side and this side are equal to each other, then these diagonals would be equal to each other. And if the diagonals are equal to each other, then it must be an isosceles trapezoid. You got it? Okay, so that's the next theorem. And then they give you an example. So let's settle in on this example. If you haven't written anything down right now, I would write this down, okay? Good. That actually doesn't look like it's at the same angle, does it? Or not? Maybe it's just my eyes. Does it? Does that? Yeah, there's a gap, but does that look like it's the same angle as that? It looks a little off. Looks a little shorter, doesn't it? But I flipped it. I don't know why it wouldn't be. Anyway, we'll pretend it is, okay? We'll just say it is. All right, so now what we're going to do, now listen, what we're going to do is we're going to do an example. We're going to put some numbers in here. We're going to give some angles, and we're going to give, I think, a couple lengths of the sides, and we are going to answer, oops, what in the world did I just do there? We're going to answer a bunch of questions about it, okay? Let me scooch it up about right there, and let's name it. I did take notes on this one, so we'll call it ABCD, A, B, C, D. And they tell you that it is an isosceles trapezoid, okay? So it's given, we'll say given, they do that in geometry a lot, that it's an isosceles trapezoid. I don't know why I made that capital. Anyway. There we go. Okay, so it's given that it's an isosceles trapezoid. So what does that tell us? That tells us a couple things. The sides add up to 180? Yeah, but you said sides, didn't you? You can't say sides because sides don't add up to 180. Okay, the angles, the base angle. Okay, so it's isosceles trapezoid. So you could say that big angle D and that big angle C are what? Equal to each other. Big angle A and big angle B are equal to each other. You could say that AD is equal to BC, right? You could say, what's true about these diagonals? What's true about AC and BD? They're equal to each other. So just knowing that it's an isosceles trapezoid, we already can tell a lot of things that are going on here. Would you agree? Okay. So let's give some information that they give.
And couldn't you say that AB and DC are?
You can say they're parallel to each other. Sure.
Couldn't you say the same thing for A, B, and B?
A what?
Couldn't you say the same thing for A, B, and B?
No, AD and BC are not. If AD and BC were parallel and AB and DC were parallel, then it would be a parallelogram. Right? You can only have one pair, right? You can only have one pair of parallel sides if it's trapezoid, okay? So here's some stuff they tell you. They say AC is 7x and BD is 4x plus 12. Okay, and they also draw some stuff inside the triangle. They tell you that this is 30 degrees. And I think that's everything that they give you. They call this point E. Yep, that's everything they give you. Now, they're going to ask you to solve for a bunch of stuff. All right, so let's write down what they're going to solve for. And we'll probably finish here. We probably won't do kites today. So I'll give you a free weekend of no homework. Write these down. Oh, wait a minute. Why did I put 125? I'm giving you the answers. All right, you guys writing this down? Sam, you're so busy talking about a kite. I don't think you're writing any of this down. I know, because I was writing the answers down and I didn't mean to. ECD.
No, I saw it up there with you. No, literally, I did too. Don't spoil it like whoa,
All right, so here we go. Yep, lots of angles. Some of them are really easy. Some of them you got to think a little bit and do some math on it, okay? Let's take a look at this. Let's do BAD, the bad angle. So there's BAD. So which one is that? It's this one right there, that whole entire thing. Now let's write some stuff in here. We know ABC, so ABC. So we know this angle right there is 125. So what do you think this blue angle right here is? It's going to be the same thing. Agree? Because they tell you. They tell you this stuff. All this stuff they tell you. Yeah, we wouldn't know that. Yeah, that's kind of off the screen a little bit, isn't it? You can see it? Okay. So let's take a look. So if this is 125, then this is what? 125. Okay? So that's my answer right there. And put degrees. It is an angle, so put degrees for it. That was the easy one, right? Right? Yeah, pretty simple, because the base angles are equal on an isosceles triangle. What about B? ADC. So there's A, there's D, there's C. That's this big old angle right there. How do we find that? That's not much more difficult.
It's 60.
Is it?
Because
The whole big angle. What did we say? Ben, you said it at the beginning. You said that this angle and this angle down here were supplementary, right? So if this is 125, what's this whole big angle? Not just this little missing one, but including the 30, that whole entire thing. How do we find it? How do you find it? 180 minus 125. And that gives you 55 degrees.
I thought that the line bisected the angle completely.
No, we never said that these do not bisect the trapezoid, not necessarily, okay?
Okay. Is that just for parallels?
It's not even just parallel. It's now I forget off the top of my head, but it's like rhombuses. Is it rhombus? That where they bisect each other? I don't know. I have to go back and look at my notes. I should know it.
180 from 125.
Because remember, right here, remember we said that these two are supplementary? Okay. All right. Yeah, you got a lot of triangles in here. And we're going to use that fact here in a minute, okay? Let's look at ABD. ABD. Which one's that? ABD, that's this. Let's do it as a different color. Let's do it in green. So what's ABD? It's that little angle right there. There's an easier way to do it. You can just look at it. I'll give you a hint. You could just look at it. Why is it 30? Because you got parallel lines cut by transversal. Very good. You got two parallel lines cut by transversal. These are alternate what? Interior angles. So if that's 30, then this is 30. Okay? You could have done it. You could have said 125 minus whatever and all that kind of stuff. All right? But that was a lot easier, don't you think? All right. Let's do ACD, this one right here. ACD. So this one right here.
That's 30 degrees.
Isn't that one 32?
That's 32.
30 also? 30 also? Right. It is 30, that's true. There's a little bit of a, to find out exactly why, what you would have to do you see this triangle right here? Okay, like this BDC, and this triangle right here, you would be able to tell that they're congruent to each other. And so this one, this angle right here, in this triangle, and this angle right here would be in the same spot. They would be corresponding parts. So they would be 30 degrees. I don't have enough time to go through that and redraw it, but that would be correct. That would be 30 degrees. So ACD is 30 degrees.
That means,
There's a,
do it just like D and D. That means the A
let's do, we only got like a minute, so let me do this. Sorry to interrupt, but we got to finish this. AED. So where's AED? AED. This angle right here. What is that? Well, let's take a look. This is a triangle. Do you see this triangle, DEC? This is an exterior angle. These are remote interior angles.
It's 30.
No, it's not 30.
55?
No. What's true about the exterior angle and the remote interior angles? The sum of the remote interior angles. You guys, it's never seemed to get this theorem. The exterior angle is equal to the sum of the remote interior angles. Okay, we've gone over that just recently, actually. We just talked about that. So this is 60. Or you could do this. This is 30, this is 30. What's this angle right here where the E is? That's 60, 180 minus 60 is what? 120. So that would be 120, so that would be 60. Okay? But the easier way to do it is just to say that that's the exterior angle is equal to the sum of the remote interior angles. All right, F. We got to find AC now. That's 60 degrees. So AC, where's AC? It's that diagonal right there. Okay, so watch. What you're going to do, that's supposed to be BD. I forgot the D right there. So what's true about BD and AC? They're equal to each other. So what do? You set them equal and solve for x. I'll give you a hint. X is equal to 4 after you do the math. And then how do I find AC? It's 7 times 4, so AC is 28. What do you think's true about BD? It's the same thing. It's the same thing. It's also 28. All right, I'll take it easy on you. I'll let you have a free weekend. No homework. We'll do the kites on Monday, then I'll give you homework on Monday.